shown. Okay, see this. One is plus, another one is minus. This is Kp plus Kds. This is 100 upon S into S plus 10. Yes, okay. For this system, my velocity error constant Kv is equal to 1000. Okay. Damping ratio equal to 0.5. Then we have to find the value of Kp and Kd. Find Kp and Kd. So this is a problem asked in GATE 2007. See once again the problem. Kp overall system is given in a form of block diagram, and then controller is also shown, which is Kp plus Kds, and forward path transfer function of the system 100 upon S into S plus 10. Okay. Now with this information, other two things which are given is velocity error constant Kv and damping ratio is also given. Now we have to find the Kp and Kd. See the solution. Before finding anything, I have to find the closed loop transfer function. Okay. Overall transfer function Ts, which is equal to Cs by Rs, is equal to Kp plus Kds 100 upon S into S plus 10 upon 1 plus Kp plus Kds 100 upon S into S plus 10. Okay. On solving this, I will get 100 times Kp plus Kds upon S square plus 10s plus 100 Kds plus 100 Kp. Okay. Now with this, it is given that velocity error constant Kv equal to 1000. Kv is equal to limit S tending to 0 S into Gs Hs. Okay, so that will be 1000 is equal to limit S tending to 0 S into Gs Hs Kp plus Kds 100 upon S into S plus 10. This n and this s will cancel. Substituting S, I will get Kp into 100 upon 10,000. This implies Kp value is equal to 100. Okay, I got the value of Kp. Now, substituting this value of Kp in the closed loop transfer function, I have omega n square equal to 100 Kp, which is equal to 100 into 100. This implies omega n is equal to 100. Okay. 2 zeta omega n is equal to 10 plus 1000 kd. Okay, zeta is given 0.5. 2 into 0.5 into 100 is equal to 10 plus 1000 kd. Solving this, I will get 1000 kd is equal to 90. This implies kd value is equal to 0.9. So this way I can find both my kp and kd. Okay, simple mathematics, and we just have to use the formulas correctly. Okay, another problem from GATE 2007. This problem involves the concept of dominant pole. Okay, a transfer function is given and we have to find the second order approximation for dominant pole concept. Transfer function if a plant is Ts is equal to 5 times of s plus 5 upon s square plus s plus 1. Okay, find second order approximation. So this is of order 3. From this we have to find a second order equation. And this second order approximation we have to find using dominant pole concept. Now what is dominant pole? Okay. Suppose I have my S plane, two poles. One pole is here, another pole is here. Suppose the value of this is -1 and the value of this is -100. Okay. So now if I find the Laplace equation of this, I will transfer function of this, I will have s plus 1, s plus 100. Okay. And in case if I find the inverse Laplace transform of this, I will get e to the power minus t plus or minus b e to the power minus 100t. Okay. So if we plot this in time domain, this term will die down very quickly, while this term with increasing value of t will die down slowly. So if I plot this, I will having something like this. If I plot this, I will have something like this. So if I subtract this portion from this portion, it will have no effect as such. Okay, so that's why the poles which are near to the origin are called the dominant pole, and the poles which are farther from the origin are called less dominant pole, or we can rightly ignore those poles. Okay, now while considering such poles, I always need to take care about the real part of those poles. Okay, so for the given transfer equation, 5 upon s plus 5 s square plus s plus 1. S plus 5 minus 5 pole is much farther from the origin as the poles produced by s square plus s plus 5. Thus we can rightly ignore this. Okay, so this equation after the approximation will be 5 upon s square plus s plus 1. So this is the second order approximation for Ts using dominant pole concept. Okay. One more question. Statement. A unity feedback control system has an open loop transfer function g of s is equal to k times of s into s square plus 7s plus 12. Okay, then find the gain k for which s, the value of s is given minus 1 plus j, will lie on the root locus. Okay, you have to find that. Generally, whenever I am plotting a root locus, I am plotting for 1 plus GSHS, okay, equal to 0. So in this again I will see for k times of s into s square plus 7s plus 12, hs is given equal to 1 equal to 0. So my k is equal to minus of s into s square plus 7s plus 12. Okay, so when I want to find the value of k, s is already given. So mod k is equal to mod of this value, which is again minus 1 plus j minus 1 plus j whole square plus 7 times of minus 1 plus j plus 12. Okay, if I found the value of this, I will get the value of k. Just we have to solve this equation, this complex number to get the value of k, and then finally you have to find the magnitude of that, because the magnitude of that is important, which is equal to the value of k. Okay. Another problem. In this problem, a Bode plot is given, and from the Bode plot I have to find the transfer function. So I'll first draw the Bode plot. Zero, 20, 40, 60. This is 1, this is 10, 20, 100. Okay. From 60, it is decaying at a rate of minus 20 dB per decade. At 1, it decays at the rate of minus 40 dB per decade. Okay. At 20, again, it decays at the rate of minus 60 dB per decade. Okay, crosses frequency axis at 10. For this I have to find the transfer function. Find transfer function. Okay. See, since initially it is decreasing at a rate of minus 20 dB per decade, so definitely the transfer function will have one pole at origin. The transfer will be something like k upon s. Then again at 1, at omega equal to 1, it is decreasing at minus 40 dB per decade. That means there is one more addition of pole at 1. Okay. Again at 20 radians per second, that means at omega equal to 20, the rate of change in the slope is minus 60 dB per decade. That means one more pole is added at s equal to 20. So that will be s by 20 plus 1. Okay. Now I can write this equation as k upon s into s plus 1, 1 plus 0.05s. Okay, this is the equation for k. Now we have to find the value of k. Value of k we can find by substituting, because at this particular value this is at 0.1. at 0.1 I know that my value of g omega is 60 dB. Okay, so I can write 20 log k minus 20 log of omega is equal to 60. Okay, so 20 log k minus 20 log of 0.1 is equal to 60. So this will be equal to how much? 20 log k plus 20 is equal to 60. 20 log k is equal to 40. This implies k is equal to 100. So substitute this value of k, I can write by 100. So this is the transfer function for the given Bode plot. Okay, when I am writing this equation, I need not to consider the other poles. Okay, these poles are not required to be considered because these poles we can neglect because the value of omega is very less. So the value of omega is very less, but we cannot ignore this one because this value of it will affect even for the smaller values of omega. So we have taken this, and this total value is equal to 60 because in the figure it is given 60 dB. Okay, so this was the transfer function for the given Bode plot. So this completes another set of problems which has appeared in GATE 2007. Okay, from this I think we have got some idea the kind of problem which are asked in GATE exam. Okay, now we will take up another session in which we will cover the problems which appeared in another years of GATE exams.